Assalamualaikum. We are from Group 6 in Section 4. Today we would like to present about the LED control system for LED 1, which is the topic is Introduction to Simulink Transfer Function. Firstly, my name is Nur Shami binti Abdul Aziz as a first presenter. In this LED 1, we need to construct a block diagram of second order system. In this lab, there are four type for second order system. So I will pass to the next presenter to explain and construct the block diagram.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Muhammad Azam bin Wan Harun, and today I want to present about over them that we have overcome it from the Simulink. Okay, first we have here the function which is CS equal to 9 over S power of 2 plus 9S plus 9, which is we had here the neutral frequency, which is WN, is equal to 1, and the zeta here uh, for damping factor is 2. Okay. Um. Now we want to set up the block diagram in the Simulink. Okay, Shamimi, you can help me to drag the step block diagram, transfer function, and scope in that Simulink.
Okay.
Okay, now then, this is uh, the diagram of a block diagram. Now we want to change the transfer function. Okay, now in this step, we want to type the value here. In that, we change 9, and the second box, we change to 9 also, and one more 9. And for the initial output, we change to 0. Okay, then we apply it, and we we run it. Then we click the scope. Okay, now here, as you see, this is the over them graph. Okay, I think that's all from me. Thank you.
Okay, now I'm going to present regarding underdam block diagram. But before that, my name is Nur Shahana binti Azhar, CE180174. For underdam block diagram, I'm just going to use the same block diagram as the previous presenter. But I'm going to change the numerator and denominator value in step function. Because as we know, for underdam, the value of zeta or damping factor must be in between 0 and 1. So now, in order to change the value, we need to double click at the step function block. And then the value of numerator is 9. And for the denominator, 1, 2, 9. And then we click apply, OK, and run. To see the output graph, we double click on scope. And then from the output graph, here is the graph of underdamp. And then from the output, we can see that the amplitude value is 9 and the rise time is 479 millisecond and the slow rate is 1.654 second. So that's all from me. I'm going to pass the presenter for presenter 3.
Yeah, my name is Aris Naziha binti Zuhiri Zain and my magic number is CE190061. Okay, for my part is to show the block diagram of for undamped system for a second system. Okay. So firstly, we design just like other system, just the different for the value for numerator and denominator function. Okay, so double click the block diagram of transfer function. Okay. So for the numerator, the value is 4, and for denominator, the value is 104. Okay. 104, okay. Then click apply, click OK. Okay, so then run the graph. Run the block diagram to get the characteristic of the damp system. Okay, so this is the characteristic of the undamped system. So from here we can get the transition response, maximum overshot, rise time, setting time of the transfer function. Okay, we can see at the right here, and then we can see the value from the block under overshots or undershots. Okay, that's it. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Safi'i bin Muhammad Saleh. My student identification number is DE190048. Okay, so I will be continuing for the critically damped characteristic. Okay, as we can know in theory, critically damped is, in theory, it has the damping factor of equal to 1. So in this block diagram, I will use the same block diagram, but only I will change the value of the equation in the transfer function, which is in the middle block. Okay, Chabibi, please click the middle block. Okay, so for the numerator, I will replace with 9. And for the denominator, I will replace with 1, 6, and 9. Okay, so for the initial output and initial input is as the same as everybody else. So click apply and OK. So next we will run the simulation. Okay, then we will view the output graph in the scope. Okay, as you can see here, our output graph is same as the theory for critically damped. So here we can see the overshoot value is in 0.505%. For settling time is adjustable, and for the rise time is 1.114 second. Okay, so that is all from me. Thank you. So in this video, we can conclude that all the block diagrams for all the 4 characteristics, which is from overdamp, underdamp, undamp, and critically damp for this lab session. Okay, that is all from us from Group 6, Section 4. Thank you.